0.06. So these first two are just a review of domain and range, but I do want to talk about number one because I know some of us are still a little confused on that, and that's totally okay, I understand. So take a look at number one. First, we're going to look at the domain. Remember, domain is all of our x values, right? And if I'm looking at the graph, my x values are my horizontal, right? My left and my right. So you're going to start on the left. Okay, well, here it is right here. It goes all the way over to -5. Okay, all the way over to -5. Now, that means I can say, all right, -5. Okay, oh, maybe if my pen will work. -5 is the rest of my x values are greater than or equal to -5. Why is it greater than or equal? Because my circle here is closed, and if it's closed, then it can also be equal to, it's included, okay? So, and these are my x values. I'm going to keep going, okay? Now, it goes all the way to 6 right here, +6. But what's different? This dot here is open, so it's not equal to, it's just these x values are less than 6. Okay, so there's my domain. All right, now we're going to talk about the range. If domain is my x values, then the range is my y values. We're looking at y values now. Now if you look, and let me use a different color here. My y goes all the way down to, it looks like, -4. Okay, wonderful. So my y values are going to be -4, right? -4 is less than or equal to y, okay, because it's included, because it's closed and it's included. Now, this is where I think a lot of us get kind of tripped up, is we want to go to where that other point is, right? But where is the top of your graph? Right here, included at 5. So your rest of your y values are going to be less than or equal to 5. And why is it less than or equal to? Because it's included in the graph, right? It's not open, it's right there. And then try number 2 on your own. Okay, but remember, think about what these arrows here mean. All right, let's keep looking. So today we're actually going to talk about another way to graph linear functions. So for this, we're going to use standard form, which is ax plus by equals c. Okay, the first thing that you're going to do is you are going to solve for y. Let me go back to my other color. Solve for y. If you're solving for y, that just means you're getting y all by itself, completely alone. We've done this before. To get y alone, you need to start moving some things around. So let's get rid of this -4x by doing the opposite operation. So I'm going to say plus 4x here, plus 4x here. That leaves me with 2y is equal to, now, can a variable and a constant go together? They cannot. So you're going to say plus 4x, or I'm sorry, it is positive 4x plus 8. Okay, but can't do anything that. Now, is y alone yet? It is not, so I need to get rid of that 2. The great thing about getting rid of the 2 is I can do that to every part. So if I divide each of these by 2, divide by 2, divide by 2, divide by 2, make sure you do every single part. 2y divided by 2 is y. 4x divided by 2 is 2x. 8 divided by 2 is 4. And look at that. What form do we have it in now? We have it in slope-intercept form, and now it's going to be super easy to plot, right? So step number 2, plot the y-intercept. Remember, your y-intercept is your b. which is 4. So I'm going to plot my point at 4. Okay, now I'm going to keep going. What's my next step here? It says, from there use slope, the rise over run, to plot the next point. So positive slope is up and right, negative slope is down and right. Continue plotting points to make your line, right? You can't say it, sorry. Make your line. So rise over run. Remember, m is your slope. So if it's 2, it's also 2 over 1. It's the same thing. So from there, you're going to go up 2 over 1 because it's positive slope. Now, I stop right there, but I can work in reverse by go left 1, down 2, right? That's not the way we normally work it, but if we have to get our whole line, we are going to have to kind of work in reverse here to figure out what that slope is. And then there you go. You have got your line. Okay, and there you go. You've done all 4 steps. Now, there's another way that you can solve this. Okay, so you can get y completely alone, and you can put it into slope-intercept form and then plot it just like how we've been plotting it. Or you can use the cover-up method. As you can see, it's already kind of wrote the cover-up method for you because this is the same problem, right? The cover-up method is where you get rid of that 2y. See, for that first one, it got rid of 2y. For that second one, it got rid of the x, and it put them by itself. But what happened is we got the same thing. We got the x-intercept and the y-intercept. For the x-intercept, it says -2. Okay? For the y-intercept, it says 4. Now, plot that point as the x-intercept. So the x-intercept, remember, that's where it falls on the x-axis. So if it says -2, I'm going to go -2. Well, if I look back at that graph we did a minute ago, did we have a point at -2? We did, right? Okay. Then it says y-intercept is at 4. So I'm going to plot. I'm going to go to 4. Well, we already knew that, right, from our graph up here. We got the same thing. We said that our y-intercept was 4. Okay? So you can solve it either way. You can use the cover-up method, right, and then connect your points and draw the line. Or you can do it where you turn it into slope-intercept form and plot it that way. Either way will work. That is completely up to you, okay? You're going to try these 2 examples the way that works best for you, okay? I'm fine with either. As long as we get the right answers, you could do either one. All right, those 2 examples are all yours today, as well as that warm-up that we didn't do. Hopefully you remember kind of how to do that. If you don't, send me a question. I would love to help you out. And don't forget, this is going to go in your Algebra 1 folder. I will see you guys next week.